Hi everyone, thanks for coming out. I'm going to do a bit of a talk about steam boilers with a bit of a sustainability net zero lens. A little bit about me first. I'm an electrical engineer by background. I kind of design, lead teams designing large buildings, so I kind of have a link to kind of infrastructure and big buildings. I've also been working on festivals. I was responsible for building all the stages at EMF this year. And yeah, do a lot of other festival bits. I also volunteer at a museum in London, the London Museum of Water and Steam, which is sort of the focus of this talk. That's a photo of one of my first projects at the museum, which was restoring Mercury Arc Rectifier, which is great fun. Not the topic of this talk. But the museum's really exciting, really cool place. It kind of started life as the Grand Junction Waterworks Company, which was 1838. It was when it started, and it was part of the kind of very first bit of infrastructure feeding water into central London. Initially, it was feeding water from canal around that area, and then they switched to taking water straight from the Thames, putting it through filter beds next to the site, and then used massive steam-powered pumps to pump the water into central London. It kind of was one of the areas where there was a kind of peak of steam-powered pumping technology, but this isn't a talk about steam-powered water pumps. That's another topic. Could talk for hours about it. But it is a talk about how those boilers are powered. You can see in the top right, that's the original boiler house for the building. Yeah, huge coal-fired steam boilers. And bottom right is one of the kind of, just for scale, the Cornish engines that pump the water around. The site became part of the Metropolitan Water Board in the early 1900s. And the steam engines were actually in use until 1944, and they switched to diesel, and then they switched to electrical engines. It's now Thames Water site. They don't pump on the site anymore, but it is still kind of a hub for lots of pipe work. The site's now owned by the London Museum of Water and Steam, charitable organisation, and you know the Thames Water do come out and dig up the lawns. On the top right there, you can see the existing network of pipes. Everything in blue there is in the front lawn is a live Thames Water pipe. So the museum's great fun. It has five original Cornish steam engines and 4 rotative engines, which have been brought in from another part of the site. And they're operational, and that's kind of a fundamental part of what the museum is about and what heritage is about, is kind of demonstrating these engines, demonstrating these things for learning and engagement, particularly with kids around steam. Now, operating these engines needs steam, and quite a lot of it. They're really big, and that's sort of part of the problem with this problem that came up. So the problem was that the old boiler that was when the museum kind of came into existence in the 1970s broke. So the volunteers originally brought the boiler from an old hospital site, Battle Hospital in Reading, when the museum was started. And it was originally a coal-firing boiler, converted to gas about the same time. It was very big. It's huge. It's like the length of double-decker bus. Very high capacity. Lots of kind of water stored in that cylindrical tank. We ran it at about 40 psi, which is quite relatively low pressure for modern steam systems. And the problem with it is about 50 rivets need replaced now. So kind of they failed their kind of yearly inspection, and it's about 100 grand to replace that. So during the course of last year, there's a decision to buy a second-hand new boiler. You immediately ask why are you buying a new gas-powered boiler? But we'll come on to that. And literally, it turned up within a couple of weeks, about 8 grand for a second-hand boiler that has been sitting in the field for a year or two. Again, not new, 30 years old. kind of originally a gas and oil dual burning, and we're just supplying it with gas. A lot smaller, about half the length, and we do know a little bit more about how its capacity. It works at higher pressure, which makes it a bit more efficient. I guess the theory of kind of having why we're still in gas, it's still hard to produce steam without gas. But the idea is less water volume will make us more efficient because we're running really intermittently. I'm just going to explain a little bit about how these work. So they're big pressure vessels, so they're a big steel tank, welded steel in this case for the new boiler. You put gas and air in, ignite it, and you get fire inside the central kind of combustion chamber. And the water around that combustion chamber gets hot, eventually boils, and comes out the top as steam. You have to pump water in under high pressure, so you need a pretty big pump to pump that water in. But that's the principle of it. It's not, in theory, a complicated system, but there's lots of bits around there. The new boiler we installed at kind of the end of last year is a triple pass packaged boiler. So I've kind of tried to indicate how that works. So you get the air coming in, the gas coming in at the front end of the boiler. You've got the burner, which combines those and ignites it. The hot gases from the combustion then go through the low bit of the boiler. Thank you. Low central bit of the boiler, and then they carry on through a set of tubes that are kind of in that water and then back again. And that's a triple pass. So the gases go 3 times through the boiler, heating up the water in each stage. And that's much better than the old boiler, which had basically essentially 2 passes. Obviously, we want to know how much better we're doing than the original boiler, so we need to monitor it and work out how we're going to control it. But the downside is this new second-hand boiler didn't come with any documentation. It'd been sitting in a field for 6 months, nothing known about it, no paperwork, apart from the boiler inspector looking at it, going, that looks okay. So I ended up taking responsibility for the boiler controls, and that was a lot of reverse engineering. So we started off with kind of initial tracing of all the wiring, building up a picture of how all the blocks connected, reading the manuals for each of the kind of discrete bits of equipment in the control system, and kind of doing a bit of trial and error. Obviously, you can't do a full trial and error because you kind of end up with a catch-22. You can't fire the controls up. You can't fire the boiler without having the controls working, and you can't fully test the controls without being able to fire the boiler. So there's a lot of back and forth and round in circles. We ripped out the oil burning controls, so that was an added complication that we were able to take out, and eventually kind of progressed through to a set of record documents, record drawings, still hand drawn, but that have over the past couple of months have been allowing people to debug problems while I've been in the field, among other things. In terms of what that physically looks like, I guess, inside the boiler, you start. That's what it looked like on arrival into the workshop, and we kind of progressed through over a couple of months doing various bits. I just can't read off my own screen. Remove some bits, and you can see in the middle, and slowly got better. Added some electrical metering. After the start of this year, added some various bits to make it easier to start motors. And one of the key bits was adding some controls to be able to monitor what the boiler is doing. Lots of things broke. Almost everything with a diaphragm on the boiler needed replaced at various points throughout the commissioning process. Lots of old electrical bits needed replaced because they were 30 years old. And the burner controller, which tells the boiler when to switch on and off, also needed replaced. In terms of the monitoring, this is what we ended up with in schematic form in terms of sucking data out of the boiler. The very basic stuff is a pressure sensor, so you want to tell what pressure the boiler's at. That also ties in with the burner controller to tell the to tell the burner controller, i.e. the fire, when to turn on and off. And that was all running through a kind of fairly off-the-shelf BMS module, so an input-output device connected back to a Raspberry Pi over Modbus, which is a kind of fairly standard monitoring protocol. We also took running signal, lockout, and feed pump running alarms, signals from the system, and a temperature sensor. And we got ended up with some nice graphs out of the boiler showing you what's happening all the time. So that's kind of the live dashboard, I guess, in terms of pressure, which is the red line that wiggles along, shell temperature, which is just a temperature sensor stuck on the outside of the steel boiler, and various other graphics. So you can see here the orange bar indicates when the burner is on, so that's when it's firing, and then the little blue lines indicate when the pump is pumping water into the boiler. They get really close together when you've got lots of steam load. So that's when we run our big Cornish engines, which suck up lots and lots of steam, and then the boiler is pumping lots of water back in to make up for that. So, is the new boiler better? That's a good question. So we have gas record use from the old boiler, so that back in kind of 2021, 2022 when it was being used, and we're averaging about 6,000 kilowatt hours a day. That varied a lot, normally varied by the people who are driving the engines. Probably one of the biggest factors is how fast they're running everything. With the new boiler, we were running things fairly consistently over the weekends since the new year. So I have a good feel of what we're actually doing in gas usage. It's worth remembering it's really intermittent operation. So these boilers originally were designed for basically running all the time. So you never turn them off. Turning them off and letting them cool down and heat up again is not very good. And it's that heating up bit that we're hoping the new boiler is better for. But we always need more data. One of the big changes between the start of the year when we were running this new boiler and the next step, which is a couple of months later, was modulation. So the way this boiler works is you've got that air coming in and you've got gas coming in, and the amount of energy that is output is a function of how much air and gas you have being burnt at any one time. So the control methodology for this is there's a motor that controls the amount of air going into the boiler. So that's your kind of input to the control system. There's a governor valve on the gas input that is in turn regulated by the gas pressure after the damper. So if you change the amount of air coming in, that will set the amount of gas coming in accordingly. And so you close the damper, less gas goes in, and the flame gets smaller. You open the damper, more air goes in, and you get a bigger flame and more energy output. So that's how you kind of change how fast the boiler is heating up. Unfortunately, when we got this boiler, the damper wasn't working, the governor wasn't working. So the first time we ran it, it was just on, just not high, but low. So it's low, set to basically the lowest value. And it just about worked. We just about managed to scrape by. It's one of the few things we can't do as volunteers. So almost everything on the boiler project was done by volunteers apart from the gas stuff. So you have to, like most cellar boilers, you have to have a gas safe or the new equivalent who commissions this, and they set the governor up. And they need to do that. They measure the flue gases on the output of the boiler to make sure we're not emitting lots of carbon monoxide or nitrous dioxide. And then once they've set that up, that's fixed. So he's been back two now, once when we didn't have it working, and once when we did have it working. So was modulation worth it? Yes. Here's the two comparisons. So when we had that damper working and being able to control the amount of air versus not. So up in December, we didn't have modulation working, and that basically meant the boiler would turn on, it would get hot, and up to pressure, and then it would turn off again. So it started and stopped and started and stopped. Every time you start a boiler like that, it does a purge sequence, pumps lots of cold air through the boiler to purge itself. So it's really inefficient. Q modulation, and we're running the boiler much more evenly. So the burner doesn't turn on and off. It's just that damper will regulate the amount of air and gas going in. So it's much smoother profile of heating. And you can see there that the red line's kind of the pressure. So up, down, up, down, up, down, up, down, all the way through the day. Not very efficient. Whereas the kind of once you're into modulation, it's much smoother. There's the output. So December 45 times it's cycled, and February 7th. What does that result in? I mean, you can't really see. 20% gas saving, not bad for a bit of fiddling around with some controls. Next steps, I guess. So obviously gas boilers are, almost a dying breed, but they're actually essential in more places than you'd think. It's not just museums. You see them in food processing plants, dairy plants, and they're kind of essential. Lots of hospitals still have lots of steam, and very hard to replace by direct electrical generation just because the loads are required. And we did look into electrical boilers, but you'd be talking a couple $100,000 just for the substation to supply the boiler, let alone the boiler itself. So if you compare that with $8,000 for a second-hand gas boiler and some volunteer labor, it's a big difference. We still want to collect more data. We don't actually know how much our steam engines use in terms of steam capacity. They're 200 years old. They don't come with an instruction manual. So we do need to put a steam meter in that'll help us do that. And we want to continue reducing our gas usage. So just like the modulation controls, how else can we make little incremental savings to the amount of energy we use? Some of that is looking at total carbon point of view. So, if we buy lots of new bits of kit, is that actually going to reduce our gas usage enough to make it worth it? Chances are no. But every little does help if we can do it with second-hand or borrowed equipment. Eventually, we want to switch off gas completely to the site, but that might be a little bit away. There's lots of good technologies out there, so it's not all doom and gloom. We're looking into a very cool technology, which is basically a rocket engine, where you put hydrogen and oxygen into a system, and that basically instantaneously combusts into steam. Quite a cool system. And then the idea would be you generate that because we're intermittent use, you'd be able to generate that hydrogen and oxygen via solar power, kind of over the month, and then we'd use up all that hydrogen and oxygen kind of in a big burst over the weekend when we're running and using lots of steam. So that's sort of where we're looking. I didn't have much more to say, to be honest. Love some questions in the Q&A tent afterwards. Thank you very much.